All right. So the purpose of this talk here is to talk about taking applications and making them cloud ready. Just real briefly, I roughly talked about myself, whereas the keynote was talking about 18 years. I did start when I was 15, so been around for a few years. My mom dropped me off in a minivan on my first gig. So that was kind of a daunting. Another cool thing that kind of happened with that is, he talked about having other hobbies in your life, and so I started with software so early in my life, and really started jumping into other things. And I do homebrewing, all sorts of other cool stuff, and I actually do take that software and put that back into my hobby. So a little bit about us and who we are to kind of set the stage for what I'm going to be talking about. Is our company, we're global. My company was acquired about 6 months ago from the United States from an Estonian company called Nartal. And we started our company 10 years ago with the principle, or I would say with the idea of how far can we take the principle of continuous delivery and bring that to customers. And so for the last 10 years, we've been kind of applying this concept of kind of modern software development into large enterprises. And that ultimately brought us into cloud. We started using cloud about 7 years ago. And since then, we've built some really fantastic, cool systems. So this talk, I'm going to go through basically what is cloud ready. And I'm also going to call it cloud native. In my mind, they're kind of interchangeable. I'll talk about where we are at now from a traditional delivery process, what's required to be a cloud native application. We'll go into a little bit of additional elements of that, of your application, so putting them into some security. And then I'll give you a concrete way that you can turn around and put this back into your team and measure your success. So to start out, cloud native is an approach to building and running applications that exploits the advantages of cloud computing delivery model. And I highlight delivery model on purpose. The way that you're building these, it doesn't actually have to be put into a cloud, but you're exploiting the concepts that cloud really brings you, the agility and the ephemeral nature of using the cloud. And so while I have this for mostly talking about cloud, you could actually apply this to on-premise solutions, providing you have the constructs for automation. So where can cloud kind of be run at? You can kind of start at the very top. And we like to evaluate our applications when we're trying to build something new and say, can we build it as a function? If that doesn't work, can we build it as a pass? Does that not work? How about if we use containers? We go on down into eventually to baked VMs and then ultimately down to the very end of just full control over infrastructure as service. At every one of those layers, you can still apply the same principles of cloud native applications. So cloud native applications have some key characteristics that will be covered throughout the rest of this. I'll be hitting these in the talk. So they're visible, they're disposable, they're repeatable, they follow a 12-factor app. I'll go a little bit of detail on there. They're secure, they're distributed, and they're performant. And obviously this sounds like something you want for all of your applications, but in cloud native you absolutely have to. So in a cloud native application, in a traditional application, they're typically built on operating systems. They're built with systems that are engineered just to handle the code that you're writing. I was at the speakers dinner last night, and I was talking to a couple of the guys, and we were reminiscing about some of the old days. And I remember building, .NET applications where you go to install it on a machine, and you're like, oh shoot, I completely forgot that I didn't have a DLL on that system. So that means you didn't have the requirements on that particular system you're building it into. So now you become kind of OS dependent. In a cloud native world, or when you're building cloud native applications, you design your systems or your applications to be abstracted away from the operating system using virtual machine or virtual runtimes and various different types of techniques. They need to be predictable. They need to have the ability to do elastic scale and right size, so you don't have to do capacity planning. Your delivery method needs to be continuous. We shouldn't have these 6-8 week long delivery cycles for a project. We should be able to deliver multiple times in a day. And then we'll get into the last bit about scaling in a moment, but then last piece is the availability for them to be auto-healing as well. So there are 8 core principles when writing a cloud native application. I'm not going to read them all, but I want to reiterate that repeatable and reliable is absolutely a principle that has to be a part of it. You'll see that most of the rest of the talk is going to deal with continuous delivery. If you have a mastery of how you build your software and it's repeatable and it's predictable, you have the ability to make changes at a very rapid pace. You need to automate everything, And then one of my favorite on here is if something is painful, do it more often. You're going to find a solution. I'm incredibly lazy, and I don't like to do things over and over again for no reason. I will find a way to make that thing more efficient. And then probably the last one I mentioned here is building in quality. You want to build in quality from the very beginning, which means you have to account for quite a few different aspects. And we'll cover those in 2 slides here. So with the 8 principles, those are the guiding principles on how you design it. We have 4 core practices. First one, building your binaries once. The idea of building an immutable binary and using that exact same binary all the way through your entire stages of deployment is highly beneficial. It allows you to say, I've tested it in dev, I've tested the exact same thing in QA, I've tested it in stage, and now I have it out in production. You now have 3 different iterations and a lot of different eyes on the exact same thing. The moment you change it and rebuild it, you've now lost all that trust that you've built through that process. Throughout that entire pipeline, as you're building those or deploying those, you need to be thinking also, how am I doing that? What you don't want to have is you build it one way in dev, you build it a different way in QA, and then you finally get to production and you build it completely different there. If you've done that, you haven't tested that process all the way through, and it puts a lot of risk on that development. And I actually got into this whole CI/CD thing, 11, 12 years ago, because I had an experience where I was sitting underneath a table. I was literally sleeping under a table at like 3 a.m. because we were doing this huge release. And eventually, I hear, on the loudspeaker here, Mike, run your check. I get up, I log in, I make my check, and I'm like, yeah, it's fine. And I go back to my sleep. And sure enough, comes around 7 a.m. and we rolled back the entire thing. And so I was thinking, this is just an absolute waste of time. We've got to have something better. And so practicing those deployments shouldn't be a one every 6 months waiting for something and going out. So if you have not heard of this yet, absolutely look this up. This is called the 12-factor app. The 12-factor app was developed by about 12 years ago or so. And the concept really says is, can we put together a series of application factors or principles that say we can now use this object or this binary or artifact as a repeatable process. Again, I'm not going to read through all of these, but I do want to say that these are sprinkled through these. I don't have them memorized, so I'll just say what the words are. But some really important ones: disposability, dev prod parity, configuration, externalized. These are all things that are really helpful. And if you want to do some of your own research, if you have not heard of this, go to 12factor.net or 12-factor. It takes about 20 minutes to read all 12 factors and then kind of see how you feel about them. So that brings up the concept of disposability. So when you're building your applications in a cloud-native world, they are going to appear and they're going to disappear. So you have to build your system in a disposable fashion. So this comes back to the kind of the old story of pets versus cattle. A pet is something that you name, you keep them, alive, and you feed them and you love them. They have names. Cattle is something that you breed specifically for one reason, and in the case of cow, you breed them so you can have steak and hamburgers and stuff like that. So if you've ever been in a room and you've had 2-3 hour conversation with your ops team saying, like, what do we name our servers? You go through everything like Star Trek terms and planets and this and that. You're creating pets, and so you need to start thinking about your applications and your deliverables as being cattle. In a pets world, you typically end up with a lot of drift that happens between your infrastructure. One thing I probably didn't mention is you're not just building applications, you're also building a lot of your own infrastructure or designing it like you would with software. And so you have to start thinking in that way too. Your applications are cattle, but so is your infrastructure. So a lot of drift happens. It means that you can log in, you change things. If we start shifting to the cattle side, now we start thinking about immutable infrastructure. It'd be awesome if I can build an entire infrastructure, put it out there. If it needs to change, I just rebuild it. I don't have to go in, log in, and do any manual changes. It has a lot of heavy focus on horizontal scalability. And this is kind of where the term DevOps is starting to, has come around. DevOps isn't a thing, it's a culture. It's the idea that you're taking operations and development and combining them together. So horizontal scale, I do want to mention there's one thing that I like to say. Don't forget about your upstream. You can horizontal scale all you want, but sometimes you have rate limiting APIs that are upstream. All right, so now we have the concept of immutable infrastructure, immutable containers, and now we want to say, how do we manage our code? So how do we even get it into the system in the first place? I find out a lot of the clients I go to, this is still a pretty large source of problems that happen, and they happen really, really close to the developer. So how do you store your code? There's really kind of three general ways. If you're using Git as a repository, there's three general ways that you can do this. There's something called GitHub Flow, and GitHub Flow uses a master branch, and every single time you want to make a change, you make a small branch, you make a change, you issue a pull request, and you pull it back into the branch. It's real simple. GitLab Flow is an adoption, it's a blend between what I'm going to introduce next is GitFlow and GitHub Flow, and allows you to have a development branch. Now, GitFlow was largely derived off of Subversion and the method in which we used to branch code there because branches were really expensive. So, in general, I think this is the generally accepted image for GitFlow. What this describes, it says that I have a branch, I have release branches. Often what I find is that customers end up having environment branches. Next thing you know, you have 15, 20 branches you have to manage, and that actually creates a person on the team. Often they are either elected, unfortunately, or they draw in the short straw, so to speak, and they have to be the person who does all the merges. That really puts a kind of a bottleneck in the process, because the person doing those merges between release branch and development branch and QA and environment, all these different things, they often don't know what those changes are, and they're just blindly making merges happen. Merges themselves aren't as complicated until you start getting into the conflicts, and that's when you start really having your problems. The pros, though, so the pros of GitFlow are that you actually have full encapsulation and you don't release software early. It was largely, GitFlow was largely derived or built because you want to put all your packages together. It was built on the model where we still release software every 6 months. And so if you have a lot of changes, you want to package them all up on one particular flow. So then next is the GitFlow, or GitHub Flow. So GitHub came out with their flow, and they said, look, you can issue, at the time they did forks, but we've now come back to just branches. You make a change, you make a new feature, you issue a new branch, you make your changes, and you merge it back down into master. At all given times, your master is the place in which you represents production, and it's where you only build production code from. Nothing else goes there. In fact, even with GitHub Flow, it's actually where everything. So if you push it into a dev environment, it's still the exact same thing. It still comes off of a master branch. There are some cons. I'm usually a very large fan of GitHub Flow. I think it's very simplistic to work with. In a smaller team, it's very easy. The cons, though, do come into you can easily release premature code if you put it in, and it's such a short cycle. And then you go to push it out, you might end up pushing code early. To help mitigate that, feature flags are a really good idea, and there's a talk later today. I'll get to it in a moment, but there's a talk later today that'll get more deep into feature flags. So what I'll often end up with a lot of the clients is they can't make the large mental leap from a Git flow into GitHub Flow. That's a pretty major jump. You're removing a lot of branches, a lot of process, and mentally they can't make that jump. So what I try to talk them down into GitLab Flow. So the concept of GitLab Flow is you either have a single branch, like a dev branch, or I'd rather almost call them like a sprint branch. And so you can encapsulate the functionality of a sprint in just a single branch. What this ends up doing is it does end up with two different types of deployables. Anything coming off of the development branch is deployable, to a development branch, should never go into production. Anything off of master is the only thing that gets pushed into production. So that can actually be pretty beneficial if you want to do a lot of snapshot builds and just testing, making sure that you have QA team. This often fits a good branch in between, or a good mental state in between multiple pushes in a day to something where your PMs or your business owners maybe understand a little bit more about the older way of software. Oh, I thought I hid this one. Oh, well, I guess I didn't. I'll skip it, though. All right. It just basically says the same thing I said, and sometimes I leave this as a leave behind. So, okay. So CI/CD pipelines. So the purpose of this is increasing the predictability and reliability. So we were founded on the principles of continuous delivery. So obviously we're fairly opinionated on it, and we've built some pretty cool solutions for customers. It started out with continuous integration. The whole point of there was, can I have all the people I work with? Does the code compile? Believe it or not, I still go to clients, and they still have the process where they check in their code, and a day later they find out that it didn't compile with everybody else. I think that's just that's a huge waste of money, and we can fix. We have tools now that do this. We've had tools that have done this. The difference between continuous integration and continuous delivery: continuous integration goes through a series of steps. Often it's a build, some sort of testing, and some sort of deployments. And I put to stage, but technically it's to any environment. It could be even on its own box. The idea is that you don't have a production ready build. With continuous delivery, you've actually automated to the point where you have that entire build or push out to production. The only difference is you often have a manual process, or you have a manual checkpoint. Somebody says, yes, this is okay to go to production. In a continuous deployment, most customers don't want to do this yet. It's because they feel they don't have the control. And so a continuous deployment means the moment I have a green build, I push. I go out to production live. And in order to do that, you have to start backing everything up and go back to the notion of, like, if you aren't ready to push to production, or you feel like a human being needs to be involved there, it means you don't have trust built into your CI/CD pipeline. So that means you need to increase your level of trust through automated testing, through various different methods of automated testing, make sure that's repeatable, and start shortening down your development life cycle, so you don't have 2 weeks worth of work. That's a lot of risk that goes into just pushing to production. Something that took an hour or 2 hours to push in, that's a really low risk. So we now have quite a few new cool tools that help us out. Cloud Native allows you to kind of change from the traditional method where we used to build, in the Java world, you built a war or you built an ear, and you would then install that into a new system. Now where we're at with a Cloud Native is you actually build the entire component all into one. And so containers is kind of become the de facto standard for the artifact that you want to generate at the end. And so my pipeline here it is what it is, but actually, sorry, it doesn't come out as well as it should. But basically it talks through same sort of pipeline, but you can start adding in additional things like security tests. You can add in performance tests. You can, at one of the stages in your pipeline, you could run something like Gatling or artillery against it and say, do you have a mean change in performance, and then fail a build if you are 20% less performant than you were on previous runs. So I do like to say that we have two phases in continuous delivery. It's not just one big long pipeline that does everything. The purpose, and I'll get into the purpose in a moment. So we have a release phase, and we have a deployment phase. Often they're linked together with automation, saying that the completion of one kicks off the next. But there's a reason why we have two. So in a pipeline here, this is maybe a little bit large of one. This has a lot of different phases and activities in it. But you have your normal GitHub flow, which is the front. You get your feature development. And then you have your automated testing and verification, image creation. And then you have a release phase. At all three of those phases, you have the opportunity to stop and go back. So at the end of your basically your creation of your image, you could come back and say, all right, well, that's not something I want to go to production. I don't want to keep going. Stop it there. Maybe your pipeline doesn't need to go that far. It's branches that, have a experiment dash as the name of the branch. But say you want to go all the way. So it's important, back in one of the principles, was that you build your binaries once, or you build your artifacts once. In order to do that, you should have a unique version that you release out to a binary repository. That's the key difference between just going straight into production versus having a two-phase process. In a release, you say, here's a known point in time. I know what's in my software, and I can go back to that version at any point in time. So then that brings up the deployment. Deployments, if you think about it, are nothing more than taking that artifact you have, or that binary, grabbing some context, and then grabbing some configuration, and saying, now go put this somewhere else. If you have immutable infrastructure and you have immutable binaries, the difference between a development environment and a production environment often is configuration changes and numbers. How many of them do you have? And so that's the context that you want to think about. And so if you can remarshal all of that context and all of the configuration, you should be able to redeploy your application to any environment you want. And at that point, you can actually start thinking about environments as becoming logical. They're no longer physical. You no longer have a production, a stage, and a dev. You now have dev-3, dev-10, whatever it is. And you just flip a label, or you flip a configuration, and now you end up with a completely different environment. So in a project, this is typically what they look like in a modern software, kind of in a modern native application. We now have declarative formats that allow us to say, what does our pipeline need to look like? We can just spell it out in code, and this allows us, again, more opportunities to have code reviews, gives us more opportunity to be very descriptive about what that pipeline is supposed to be doing. There's quite a few different CIs out there that allow this. I'm starting to see, and I'm becoming a really big fan of having your repository and your CI work together, because then I have all of my activity for my application in one location. At the completion of that, we should be building some sort of an image, and so a Docker file is often another thing that is usually looped into all of your code, and it should describe what that Docker image looks like. So artifact versioning, you're probably going to have a couple different versions or ways that you want to create versioning. Docker itself is very easy to create a version for. I've got opinions that I won't go too deep into this, but opinions on semantic versioning. In a Docker world, it doesn't really mean a whole lot, because you're going to be building a ton of these Docker images and pushing them out into a Docker repository. Whereas if you get into Helm, Helm is a package manager for Kubernetes. I highly recommend using that, at least right now, until the industry has a better solution. I think Configure's coming up on my mind for that, but until it becomes a better version, or sorry, better system, you have the ability to say, I want version 1.0.1 to go in. 1.0.1 knows which container it works with, knows its configuration, and can manage the lifecycle of the entire application in Kubernetes. Oh, I did forget to mention here, another good little kind of tip is using labels or tags on your Docker images to indicate what part of the stages they have been through. Because it's the same image, you can add additional labels to them to kind of help marshal it through and know what stage and what's been approved. All right, so moving on. So now we have to talk about, we've talked about disposability, we've talked about predictability and building, and now we get into distributed. Now, cloud native applications, to be distributed, they need to be discoverable, they need to be fault tolerant, you need to think with an API first mentality, and then we need to talk about it from a decoupled perspective. So decoupling first. So decoupled applications, you're going to have hundreds of these applications, cycling through. If you're doing, 10 builds a day, 5 days a week, that's 50 that go out. Those are the ones that are only going to production. Start compounding that over the entire year. Now you're talking about a lot of different applications. They have to be decoupled from each other. The whole intention of having even microservices is to say that I have an independently built solution that doesn't rely on other systems, so I don't have to coordinate all of these different activities. And so designing your application specifically to think for that, domain-driven design is a great idea to come in. Again, there's another talk, I think Pim was his name. You can find him around here. He had a really good talk yesterday, and I think there's another couple conversations out there. It's a great thing to look into. Eric Evans was kind of the, I guess you should say, the godfather of that. Outside of that, for decoupling, it's not just a domain. So now you've got your application, it's on its own space. And now you have to say, how do I expose this and how do I talk to other components? So a great way to do this, first answer the question. When I talk from one application to another, does it need to be synchronous or asynchronous? Do I need to have multiple other applications or other services that need to respond to the same data? You can then make decisions like, do I need to use a queue? Do I need to use RESTful APIs, gRPC, something along those lines. So queues generally come in three formats. There's the at most ones, which is kind of a fire and forget. There's the at least ones, which is making sure that it is available. That message is always delivered, but it might be delivered multiple times for the same service. And so you have to think about item potency for your applications. And the last one is exactly one, which is a lot more difficult to do. And those are more your log streams, like your Kafkas and Kinesis and stuff like that. An important thing to think about too when you're making these things decoupled, creating in some sort of an API. It doesn't have to be a public API, but just an API in general. So that way you can swap out your interfaces. One thing we did for one of our large gaming companies back in the US is we developed two different levels of APIs. We had the public layer, and we used a very large API gateway for that. And each of the services had their own APIs, and so we had a translation layer. And that allowed us to make changes to the systems underneath. We could even change the APIs, and we didn't have to go back to the public and say, by the way, now you have to use something different. So making things fault tolerant was the second aspect of distributed. You have to plan for failure. It's going to happen. There's nothing you can do about it. You can hope all you want, but your system's going to go down one day. Someone's going to fat finger something, like Amazon did and took down S3. Fat finger little things, nothing big. And so you design your systems to have new methods. One of them here is called a circuit breaker. And the idea is that if I have a chain of applications and I've broken, and they're broken up, so it represents a series of services. One of those fails, I don't need to keep calling it. It's not going to help. And so I can stop it and break a circuit. So if my system fails for some threshold, say maybe it's 5 times in 30 seconds, I now put up my wall and say, here's a default response. Give me time to catch back up to where I need to be, and I'll start serving. So it's a great thing to think about. Right now, Java brings that in with Hystrix. It's a Netflix API. And I know that there are other libraries out there for other languages that do the same thing. One thing that's really cool, though, is that's now starting to be abstracted out of the applications into the service mesh layer. So I highly recommend the service mesh talk. It's going to be awesome. I talked to the guy, I don't know, for like 2 hours last night. Service meshes are allowing us to take, because it's a control plane, allows us to take a lot of that functionality, pull it out, and allows our applications to be polyglot. The languages and frameworks that we want to use, that we like to use as a developer, may not have the features, and so you can kind of push it up. All right, so distributed. I'll go through this lightly. In order to be discoverable for your applications, you've got hundreds of these coming in. They need to have new versions available. Service discovery is the answer for this. Service discovery has been around for years, like 25, 30 years, in a concept generally with DNS or in something similar to that. The general idea is that you ask for a service. Service says, here's the IP. The service, when it comes up, it registers itself and says, it's an address book. Here's where I'm at. Come find me. The newer concept that's coming out, or has been out for a couple of years now, has been the client-side version of that, where as a client, rather than going and registering with a big service and having that be the only interaction, it then pulls down a local version of all of the other services that it needs to talk to, and then it will do a peer-to-peer, but from a client-side load balancing rather than from a external load balancer. So that's a really cool system to kind of look into. And then the last bit of these is observability. Your application has to be observable. If you've got, I think at any given time, I read somewhere where Netflix has over 4,000 versions of their software deployed at any given time. And so in order to be able to even think about managing that and governing that, you have to think about what your visibility looks like. And so this is the idea that logging has to be externalized. It can't be something where I need to find out what's going on. I go log into that individual system, go down to the logs, I start tailing them and say, oh, I don't know what happened. So externalizing that into a log aggregator is important. But now when you start saying, I think that concept has been around for a long time. So now you start backing it further and you say, now I've got polyglot systems. I have Java who's talking, nodes going on at the same time, and maybe Python. Those logging systems all going to have slightly different log messages that come out. So take some time to plan out what those log messages look like, and also make a series of principles as to what logging levels mean. So you don't have your Python application throwing everything out to error and your Java throwing everything out to debug, yet they're the same level. So take some time to think about that as well and plan it. The last thing I want to mention is metrics. So metrics are kind of a newer thing in the industry, but if you have not read the Site Reliability Engineering book, I highly recommend it. It's very, very heavy on the concept of using metrics to create what are called SLOs. An SLO is a service level objective. And what that means is if I have, say, a system, rather than looking at CPU, RAM, and IOPS and saying, is my system healthy, you look at it and say, how many people have logged in? And if you know that your pattern is at any given time there's 20 or 30 people logging in and that drops to 0, that should be an indication that maybe something's not right. And so you start thinking about using attributes about the system to determine its health. In order to do that, you need to emit business metrics. And so thinking about putting together a data model saying, service name dot, feature dot something in some method will allow you to emit those out and get those within moments of something happening. Then make a determination as to how you want to handle it when you get a failure. So the last piece of this here is all your cloud native applications need to be performant. And so you need to focus on your boot time. And when I say this is if you have a container that takes 2 minutes to boot or an application that takes 2 minutes to boot, you're going to have a very different characteristic set for your orchestration and your deployments when you start saying, I want to auto-scale this. If you have a 2 to 3 minute boot time and you tell AWS just randomly auto scale this, it's going to say what threshold do I do it on. You're going to end up at like 30 and 40% CPUs, which means you're going to be highly inefficient because your system's going to start saying, I don't have the time between that threshold hit and new services coming up in order to serve the traffic. And so it's going to try to be deterministic about that. So along with that, Know what your usage requirements are. If you know your application takes 2 to 5 minutes or 10 minutes to boot up, build that into your software and make sure you use that as an informed decision for scaling up and scaling down. Know your synchronous. Do you need to make everything synchronous? A lot of the time the answer is no. The first mindset is going to be, yes, of course I do, but when you really start diving in more, you realize that you don't, or you can think about it differently. You can think about event streams. You can think about, service A calls service B, B calls C calls D. What if I throw it on a queue and A, B, C, or B, C, and D all talk to that same queue and do their actions in a asynchronous format? So think about those. And the last part is just your monitoring your application performance. So using tools to make sure that you're visible and available. It's no longer just for operations. This is for development teams too. Most of the clients I've gone to recently, we've been using Hygia, which is a dashboard that allows you to see metrics about your app, your team. You can create different ones for product owners or for ops folks, but primarily it's for the development team. You can see how many failed builds you've had. You can see how long it takes to close tickets. You can see how many deployments you've done. You can see a lot of different cool metrics. So I definitely would take some time and invest into that. It empowers you and your team, and going back to the keynote, it makes you happier because you feel like something's being done. All right. So I'll briefly go through this. There's a whole talk on this, DevSecOps. So I don't have enough time. They only give me an hour, so I could probably talk for 4 or 5 hours, and you guys would be asleep by then. But anyway, DevSecOps is the idea that we have DevOps. We're building in all of our functionality into automation, and then at the very end, before you go to live, there's only 2 people in the entire organization, 2 groups in the entire enterprise that can really say, nope, that can't go out live. You've either got legal or you've got security. Legal says it's illegal, that can't go out, and security says there's a vulnerability, we're going to be sued. So other than that, it usually involves 4 or 5 people arguing whether or not something should be released. So there's only 2 people who have the unilateral decision. So let's bring them in as early as possible. The moment you can, let's try and find vulnerabilities right away. There's really 4, or I guess there's technically 3, but a 4th categorization of DevSecOps has kind of come out. Static analysis is the idea that you're going to use static code analysis tools, linting tools. If you're in the Java world, you might use PMD and checkstyle. And you can start using dependency scanners as well to say, does my dependency have a known vulnerability in it? So that we can automatically start eliminating libraries and dependencies that are known vulnerabilities. Dynamic analysis is the idea that you're going to start looking at your code after it's already been running. So this is hitting endpoints. This is using things like OWASP. They have a ZA proxy. Allows you to check against OWASP top 10, or at least most of them, against your application. Interactive runtime is it's now live, and you're passively collecting information, trying to do an assessment in an offline system or an outside system. Am I at a security risk? Am I about to be attacked? Is there something going on? It's kind of a threat analysis. And then the runtime self-protection is basically an extension of the interactive runtime, which then says, I'm now proactively going to make a decision on the fly. Is this something I want to allow in? So where can we apply these into our systems? In the CI/CD pipeline, you absolutely can apply static analysis and dynamic analysis. And you absolutely should, even starting today. Go in and you can run, stop by our booth. We've got a cool little map that talks about technology. I'll point them out to you and tell you where you can apply them. It's really, really low effort for really high gain to just check your dependencies. Your infrastructure as code, and when you're building your infrastructure, so in some ways it is kind of in your CI/CD. I fully believe that when you write infrastructure as code, you put it in a CI and is governed by that CI the entire way. Then you don't have a single human running this. It goes through the same checks and life cycles. All right. Okay, so here's just a real simple example just to kind of show something that can be done for your DevSecOps. This is a product called Gauntlet. It allows you to use behavior-driven testing to say when something happens, I want to expect. This test here in particular is saying I want to use nmap to say what ports are open, and I better find out that I only have port 80 open. If anything else is open, or in this case, if port 25 is open, then I need to fail the build. All right. Last part of this is with your security, externalizing secrets. Again, configuration needs to be externalized in general, and so push all of your configuration out. Secrets need to be a part of that. They shouldn't be in the same batch as the rest of your configuration. So use tools like Vault. Vault's a great, awesome tool to use. There are secure secrets that happen for AWS, Microsoft, and Google as well. Allows you to use APIs to fetch and pull your configuration. Last part is rotate your certs. We now have industry has created a protocol called Acme, and allows you to interactively recycle your certs and move your certs around and rotate them on a programmatic nature. So to kind of conclude all of this, all of these things that I talked about in really, really brief, sorry, I wish I could go deeper on all of them, but I can't. There's a way that you can make this concrete on your team. What we do is I've broken it down into kind of like a linear path of 5 steps. You have design considerations, you have build considerations, tests, deploy lifecycle, and monitoring. So what we ended up doing here is we have an ongoing, and this is just one example, it doesn't have to be a spreadsheet if you don't want to, it can be any way you want, it's the concept you want to do and build it for yourself. The idea is that I'm going to take 15 minutes at the end of every sprint, part of the retrospective, and I'm going to say, all right, or maybe you do it every other sprint, some cycle that you want to go through, and you say, all right, on design, what's the maturity of our CI/CD pipeline? We at our company, we've actually defined, I've probably got about 15 more of these items in the different segments. We've defined what each of those mean and what the metric of 1 and of 5 means. And so we can go back and say, what is my maturity? And now I can map that over time and say, are we getting better? Are we becoming more efficient? Are we becoming more mature with our applications on a visual perspective? I like to say, make this personal. Sometimes some of these factors don't matter to you, so don't put them in. Sometimes other ones do. So build out a little maturity model for yourself and track it with your team. It's a good way to see progress. It's also a great way to kind of influence your backlog as well, to say, I have technical debt. You can go back to, again, in the keynote, you can go back to your PMs and say, here's some statistical information as to why we need to hit this level of maturity with databases. If your databases are manually run, that takes a lot of time. You can quantify that and give it back as a piece of information. When you make it visible, then they're able to kind of see that. So I put this in last night after talking to a lot of the other speakers. If you do have a phone, this is one time, you wouldn't be a bad one to look at. There are, wait, why is that? That's weird. Forgot that I had an animation on that. Service mesh, Matt Turner's talking. If you want to know more about feature flags, Andy Davies is going to be doing it. If you want to talk about unit testing and increasing the capability of unit testing, Jorge's doing that, chaos engineering, etc. And I put the last one just because I think it's a really cool idea. I wouldn't use it in production, but it's a cool idea to use Git as a database. Might be a fun one to go just as another fellow nerd. So that's what I recommend going to see that comes out of my talk. So.